Hi everyone. So today we're going to talk about the second method of solving a system of equations. This is the method of substitution. So we saw last section that if you are able to draw two lines, no matter what form they start out in, when you find out where they cross one another, you're able to identify the solution to the system. So for today's, I'm just showing you two examples, and for each one of these, I'm rearranging them into y equals mx plus b form. I graph the two, and I'm able to obtain, it looks like they cross at 2, 1. Well, that's well and good for graphs that cross at a very nice location. But sometimes we get graphs which you just really can't tell exactly where it is. So you need one of our other two methods. Method number one, or our second method, is substitution. So our series of steps to be able to figure this out is, first we want to set one of our equations as an isolated variable. That means we want to get one of them so it says either x equals or y equals. In my example, I've chosen y equals from equation number 1. 2, we're going to take this result from equation number 1 and we're going to substitute it into the y position in equation number 2. The rest of equation number 2 we leave as is. What we're going to do then is multiply the negative 3 into the brackets. We're going to solve for our first variable of x. Just rearranging it here, and we get x is equal to 2. Then we're going to take that, substitute it back into any one of the original equations. I'm going to put it back into equation 1 where we set it up to solve for y. And we find out that y here is equal to 1. So our solution then is at 2, 1, which, yes, we saw with the graphs, but we're going to need this process for more complicated types of equations. Again, make sure you put your answer in coordinate form. All right, let's look at another example. Suppose I have x minus y equals negative 1 and 3x plus 2y equals 12. I'm going to take equation number 1, move the negative y to the other side to get x is equal to a negative 1 plus y. I'm going to substitute that into the x position in the other equation, equation number 2, solve, and I get y equals 3. Substitute that back into one of the original equations, and I get 2, 3 is my answer. Next example. This time I'm going to take equation 2 and rearrange it, because I don't want you to think you always have to work with equation 1. I'm going to take the x value from equation 2, plug it into the x value from equation number 1. It allows me to solve. This time I come up with one of these nasty numbers. Y is equal to 17/13. I'm going to take that, plug it back into an original. I rearrange, find my common denominator, and I get y equals a negative 16, sorry, x equals a negative 16/13. Good luck finding that answer by drawing two lines and finding out where they cross. Next example. 5x plus y is equal to 2, and negative x plus y is equal to negative 4. You might want to pause your screen here and try and solve this one on your own. You can see this becomes very systematic. We just keep plugging things back into the original equations, etc., get an answer, 1, negative 3. Sometimes we get equations that aren't quite so nice to work with. We've got fractions involved. Well, I can still rearrange, get one of my equations as an isolated variable, multiply by fraction in. This one actually works out quite nicely because the 12/12 becomes just a 1. I rearrange, I times both sides by 4. Be careful with your fractions. Make sure you're going through this one carefully. Divide both by 5, which is the same as timesing by a fifth. And I get y equals 1/3 as my first answer. That's not a bad fraction. Plug that in, solve for the other one, I get -1. Got scared with the fractions at first, but it turned out to be not that bad. So I have a little bit of homework for you. Page 425, numbers 4 to 6, 15 and 19, A and C. I'll see you on Wednesday. Bye, everyone.